You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcast, and I have Dr. Samantha Nazareth. She's double board certified in internal medicine and gastroenterology/hepatology. She practices in New York City. She's a noted researcher, writer, and speaker on nutrition, wellness, and the microbiome. And she has had research published in the New York Times, and she's sought by media as an authoritative source on a wide range of topics that include eating, wellness, and gut health. She's been featured on CNN, Huffington Post, U.S. News and World Report, Women's Health, and many other places that I've never been featured. So that's excellent. So, Samantha, thank you for coming. How you doing?
I'm great. That's excellent. Thank you for that lovely intro.
Yeah, I once told a guest that they had been featured on Oprah 34 more times than I had. They had never been featured on Oprah, so I thought that was funny.
I would love to put that in my bio at some point.
Yeah. So tell me about your work. What attracts you to learning about the microbiome and gastroenterology and all the work that you do?
Oh, yeah. I guess I'll start with gastroenterology, or it's known in some circles, GI, gastro, all of the above. I had a love for the insides of people at a very, very young age. Sounds very creepy, but I definitely was the little person always on, using that operation game, and even like on school trips, going to like museums and whatnot. I was in gift shops buying skeletons that you can create and build and put organs inside, and also like even eating breakfast on top of placemats with organs all over the place. So it wasn't, needless to say, I think nobody in my family was that surprised when I went into medicine. But even before that, like I did, it was like a summer program in high school, and I had a really cool opportunity to even do like anatomy, physiology at a medical school level. So I was able to start dissecting on human cadavers at like 15, 16 years of age. And I was always like the first person to say, give me the scalpel. Like I dove right in. I was never afraid. I was always curious about understanding what was not seen, typically, because that was like the most interesting thing. It's like, what's happening inside this enigma of our bodies? And, I entered medical school with the thought that I would become a surgeon, which, made a lot of sense given all those interests that I had. And during medical school, operation, that's like real life operation. And while I was in medical school, my mom, she got diagnosed with colon cancer. So, with that, and that was pretty early on in my education, I learned so much about GI just because of the care that she was getting. And I really wanted to be well informed of what was happening. And I realized, GI also, I could work with my hands. I can see inside, and I love the guts. So it was kind of a nice marriage of all of that. And it fell into place in sort of that timeline. And to answer your second question about microbiome, I really learned about it also when I was doing my GI fellowship in New York City at Columbia. The fellowship program requires all of us to do research and identify a research mentor. And I mean, there are amazing, amazing people at Columbia. And one of them that I worked with was Dr. Peter Green, and he's very, very well known in the celiac disease space. And so he was my research mentor, and then we started doing some research on probiotics and celiac disease patients. And that led me to I had to really learn about probiotics. And that's really how I think the general public has become interested in the microbiome, is because of the entrance of probiotics. And now everybody knows what a probiotic is. Back when I was doing this research, it was like, yeah, it was getting popular, but it wasn't so mainstream as it is now. Like, I mean, I see it everywhere, like even in food and cosmetics. It was only a supplement back then, and now it's just completely mainstream.
So what is your research turned to? What are you working on lately?
I'm more clinical now. I used to do a lot more back then, but now it's straight. I'm just like, the doctor that you see in the office, seeing patients and doing procedures and clinical care at this point.
Okay. So what's the focus of your clinical work? Do you see people with, gastrointestinal distress? What kind of issues are you commonly getting in clinic then?
I see just about everything you could imagine with GI and bread and butter. And that usually, I would say like the top things that I see are bloating, gas, constipation. I would put that in like one category. A lot of acid reflux or heartburn. And then also just bleeding, like anything related to hemorrhoids, bleeding, pain, anything down there, essentially. Those are probably the top three things that I would see on a majority on a day-to-day basis.
Yeah, one thing interesting I've seen with bloating and, gas and all that, a lot of people seem to be prescribed proton pump inhibitors, and it seems to be the opposite of what actually works. I had one nutritionist that recommended I take tablets of HCl. It was literally like not pure hydrochloric acid, but it essentially would increase the stomach acid. And he told me that a lot of the proton pump inhibitors and, Malox and things like that, they decrease stomach acid, which makes it even harder to digest things. So it's going the wrong way. And I noticed, like, for instance, when I would take, these HCl tablets, that it would help much, much more to, when I had stomach distress. I mean, obviously changing the diet would be far better, but at the time, it was just one interesting thing that I saw. So I don't know, but I guess I'm just telling you what I see. But what are some interesting things that you've run into?
But even along with that, because I get this question a lot with specifically acid reflux, is this too much acid, too little acid? And you're referring to Betaine with Pepsin, which is something that you basically are giving acid back in a setting where maybe your symptoms are from, lower acid. And I always caution anybody who's taking that, you definitely have to be ruled out for ulcers. Like, you cannot just throw in, HCl or Betaine with Pepsin without knowing, do I have ulcers or not? Because on the flip side, yes, proton pump inhibitors definitely have and then all the studies keep coming out more and more of long-term usage and all the side effects associated with them. But in the setting of a bleeding ulcer, this thing works, and it works really fast. If someone comes in to the hospital and they're bleeding from an ulcer, this drug is given IV, and I've seen this because I've literally have done an endoscopy in the beginning of this course of hospitalization, and I've seen what the ulcer looks like, and then I've seen it a couple of days after they've been giving this IV, proton pump inhibitor, and it heals it. I mean, very, very quickly. Not completely, I would say, but it does. And it's again, like, you have to be very personalized when giving any drug or any supplement. It's not a blanket recommendation like, hey, if you have this, this equals that. But I've seen, especially in bleeding ulcers, that drug, it works. And what I think has happened over the course of, several years is that there's a subset of patients that end up in the hospital, and then basically after they stay on the proton pump inhibitor because, they've had ulcers, but now we're understanding with all the research that's been out that this is not just a benign drug, even though it is over the counter and people have access to it, but it's not completely benign, that people actually have to come off the drug if it's not indicated, or if, a certain time period has passed. And that's definitely true, especially given the rise of like C. difficile and things that it's been linked to, that is definitely concerning. So my job is usually to say, okay, do you have ulcers or not? Because that's a whole other set of treatment plan than if it's not, you don't have stomach ulcers. And then we have to explore, what is your lifestyle like? And the biggest things are like eating late at night that I've seen is a huge thing, and specific foods that can trigger it. But yes, that is a common thing that I do see.
Yeah, what are some of the causes, for instance, possible causes of acid reflux or bloating or abdominal pain after eating, or in general, what are some of the possible reasons for these things?
Yeah, I always try to rule out like the big scary things. So having an ulcer obviously is not great and a big scary thing. So that's one thing. Secondly, even infectious things that pop up like H. pylori, even small intestinal bacterial overgrowth, which is not a true pathogen, SIBO as it's called, for small intestinal bacterial overgrowth. It's really just almost like translocation or movement of the bugs that live in the colon to a different place, into the small intestine that they're not supposed to be there. But it kind of falls under that, like bugs are where they shouldn't be or acting up. Those things have to be ruled out as well. And then, if all of that is ruled out, then lifestyle factors like eating late at night, even certain foods that just take a long time to digest. Usually it's like fried fatty foods that just hang out in the stomach for a long time. And this I've always seen, even doing really early morning procedures. When I do an endoscopy, obviously, we tell people that they have to be without food for 8 hours. But in some people, even 8 hours, I can tell that they had pizza from going inside. Yeah, it's like, and it obviously doesn't look like, a slice of pizza inside, but I imagine, right, my surprise, like, oh, I know what toppings you had last night.
And what if you're able to say, that's from Delmonico's on 12th Street?
Exactly, right? That would be completely creepy, and the patient may be running away from me immediately. But every time I've seen something like that, it's always something fatty, greasy, pizza-like that they ate the night before, even despite clearing, having the 8-hour window of not eating.
So why do you think that happens? Why do, those fatty, greasy, fried foods do that? Why is the stomach emptying so slow? Like, what's going on, biologically to cause that?
Some people, it's, just generally, it is not harder, but it is slower for that specific food category to pass through the stomach generally. But then if you add another layer of, well, what makes it even more delayed, or what makes the transit, that's like a fancy way of saying it, the transit time or the movement time of the intestine smaller. And biggest things, I would say, one is diabetes. If the sugar is not controlled, that heavily affects transit time or the movements of the stomach, and even, further down in the colon. And you can imagine, like, diabetics have nerve issues, right? Like, if you have tingling in the bottom of your feet, what's called neuropathy, it could affect your gut. It makes sense because the gut has lots and lots of nerve endings, and it's basically under control from these nerve endings to move. So just like high sugar can affect the nerves on the bottom of the feet, they can definitely affect the nerves up and down the intestinal lining. So there's that. And then a big one that I see are medications.
Well, quick question. So have people observed clinically that people with diabetes tend to have, in general, slower gastric emptying and slower transit time through their digestive systems for any kind of food?
Not all diabetics, but there is, yes. And then that diagnosis is usually called gastroparesis. So, and that's something that is well known within the medical community. Yes.
So maybe what happens when food enters the stomach is that you said there's a lot of nerves there. Maybe there's signaling going on. The stomach is analyzing what's in it, signaling ahead to the small intestine and to the rest of the digestive tract, and saying, we're not going to send you anything for a while. We've got to eat away at this.
We have a lot of work to do.
Yeah. Do you think that that's going on? I mean,
well, even from
throughout the digestive tract?
The minute that you know that food is coming, there's a whole coordinated system of eating, from salivation to basically preparing for the entrance of food. So you have that, and then you also have the taste of food. Obviously, you even know, like, if someone's sugar is low, you give them some candy, and that just hits their tongue, and that immediately affects their sugar. So even the taste of food, your body is knowing, okay, what's going to come down, and it really signals it as basically the macronutrients, which is carbs, fat, and protein. So your body's already aware of what's coming down. Now, the stomach's ability to stretch is also a signal to the brain. So if you think about it, like, the stomach is kind of like the size of a fist sitting, but it's allowed to stretch from that point, like from that little fist. You can stretch it like a balloon if you just set. I mean, you could see, like, those people that do all those eating contests. I mean, they can eat a lot because their stomach is allowed to stretch a lot. But there's signals that go from that stretch to your brain to say, okay, stop, this is uncomfortable, I'm full. And even signals going down like, I'm still hungry. So there's just constant communication from the minute that food is even presented, or the thought that you're going to eat, all the way down to as it enters down. And then even as things are in the stomach, there's kind of a final sweep too, called the MMC, or the microeating motor complex. And it's like, I always think of this as, you know, the Roomba, those little cleaning things that you could set free in your apartment. It's kind of like that. It's like the final sweep. Like, it's gonna go around and, like, clean up the things that maybe you didn't see, or just get everything down where it should be. It's like that. It's a final sweep of the digestive, the stomach, to move things, sweep them along into the small intestine. So you can see, like, all of that is so coordinated with nerves, pathways to the brain, and that is so coordinated in that sense that, we don't think how hard it is to eat, but our bodies know how to do all this thing in the process.
What do you think would happen if I ate a standard meal, and then I looked at a piece of pizza and I thought to myself, I'm going to eat that. Do you think that just by doing that, my body may speed up the processing of the existing food in my stomach because it thinks that this other food's coming that's going to take a while to digest and take a lot of effort? I mean, what do you think that would do to me, in terms of how fast I digest?
I don't think it would affect it. I'm just thinking, like, you could override your signals clearly if you're, if you think and your body's like, I'm full, you could obviously override it, because a lot of people make room for dessert. But I don't think the body would clear it faster knowing that the extra food is coming. That would be really hard to study, but I don't think that it would do that.
Yeah, I just wonder because, again, you're getting visual signals, and, like, people will salivate before they eat, or if they think about food, like you said, it starts a whole chain of reaction. So there's a gut-brain communication here that's happening. So I wonder if you eat a meal and you eat dessert first, what that would do to you versus eating the proteins and the carbs and all that stuff first. I just wonder what having this in the presence of that, having that in the presence of this, or not in the presence of it. I would think that all those things would inform how you digest and maybe change it, but that's just speculation.
Yeah, I mean, we know this from the absorption of sugar, really. Like, if, like you were saying, the dessert first. Like, if you do dessert first with nothing in your stomach, the sugar does get absorbed faster than if you had something sitting in your stomach and then you had dessert. But in terms of digestion, there's really there's not like a quicker way to actually move things along. There are medications that could do that, but just from like a mind-brain type trick, there's really none that can do that to make things move faster as you're eating. The other thing too is most people are rushing, not really in that mind frame of I'm going to sit down and eat. And that kind of speaks to the sympathetic and the parasympathetic nervous system. And even with that, like, the sympathetic is basically I got to do a lot of things. I got to, check my iPhone. I got to do all these like tasks and read emails and everything. That's sympathetic. Before that, it was like, I'm going to be chased by like a tiger out of the cave. And then the parasympathetic is, it's rest and digest time. It's time to eat. And I have to admit too, I mean, I'm probably not in a parasympathetic state every time I'm eating, just because of, well, one, I'm in New York City, so it's really hard to do that. But you understand what I mean in that sense.
Yeah.
And that also affects digestion, because that parasympathetic sort of mind frame is helpful for digestion and the normal processes of digestion, which is different than sympathetic kind of mind frame, which is not meant to rest and digest. It's meant for you to like kind of be on adrenaline.
Well, so, I mean, here we go. So now we are saying that your mindset does affect, your eating experience. So,
yeah.
Have you seen any studies that show eating with a certain mindset in a relaxed state, in a stressed state? I've experienced this myself. That I think there's got to be a correlation. If I'm stressed, I may not want to eat, or I may want to eat. If eating makes you feel better. Or, again, I may not want to eat when I'm stressed. Or if I'm stressed and I eat something, I may get indigestion when I normally wouldn't. So it definitely does seem like, the condition of your nervous system and your thoughts and all that affects, the digestion process.
In that sense, yes. If you've already eaten and you're trying to trick your body into eating more, that's a little bit harder to do, because once you're kind of in the mode of eating, it's a little bit difficult. But before you eat, getting into that mind frame, and even while you eat, and that's sort of something that we've kind of strayed so far from, like eating in a group setting and taking the time, these more than half hour even lunches, longer than that, like that's so rare now.
Well, what about physically what you're eating? So what happens if I eat, a slow digesting, if I just eat meat, I just eat like a steak for lunch, that's it, nothing else, versus a steak with like a big side of vegetables. The vegetables, legend has it, digest a lot faster and move things through the digestive system faster than meat. So what happens if you have just meat, or if you have meat and vegetables? What does the combination of vegetables make the meat move through faster, and therefore it's less digested than it otherwise would have been? Have you seen any studies that look at this?
No, the only thing is really the feeling of fullness. Obviously, with the veggies, you're going to feel fuller a little bit faster than if you just had the meat, even though meat is on itself is full. It's pretty filling. But in terms of movement, it's really shown specifically for vegetables, because that really highlights fiber, that yes, if you have fiber in your diet, then your transit time, more so than kind of the downstairs portion, like the colon, is faster, just because it helps move things along. But in terms of like affecting absorption, no, but it will help move things along if you have fiber added.
Oh, all right. So what about, why would it help things along if you have fiber added? Or if I'm going to take probiotics, should I take it before my meal, after my meal, during my meal? And why would one of those ways be better than the other?
So probiotics. So this is, it's interesting because, one, there's been some studies that show that even the probiotics that you take don't even stick around. So it's one of those things of, does it make a difference of when you eat it or when you take the supplement? Perhaps, and then some people would say, well, then you should take it like last thing before you go to bed, because then you're not really bombarding your probiotic that's there with food. I always just tell people, just read the label and just follow it, because there's so many different kinds out there. And at this point, I don't know what's going to stick around in your gut. The mechanism that probiotics are thought to work is perhaps in small subsets, they do, stick around, and then they kind of pass through and interact with the microbiome that currently exists, and then exit as you flush the toilet. So, does it matter then what time of the day, with food or without food? I would say just follow what's labeled on the bottle, because it depends on how they've manufactured it to be delivered inside the body. And now that there's so many different forms of probiotics, I can't even just say it's a pill form. I mean, there's powders and there's liquids, there's everything. So it's even harder to kind of say that in a broader sense.
Right. Well, what are some of the big questions that you want to have answered, in your clinical work? What are some of the frustrations you wish they were an answer to or more insight into?
I really would, because I know how hard it is to study the microbiome in itself, and this research is really, really new and early. the question I get a lot, and of course I'm thinking about is there really, will we ever get to the point where we could say what a normal microbiome really is? And also, are we really sampling the right part to really get a snapshot of a patient or even an individual of the microbiome? Because right now it's basically the last half of the colon, because that's what we poop out and that's what's really accessible. But is this the microbiome that's really the most important, or is it more like a deeper one, in the mucus layer, or even more in the mucosa layer, which would require a biopsy? Because in different parts of even the colon, there's different bugs that live in different areas, and which area for which disease is really most important, and how are we able to follow that over time, because anything can change that microbiome. Perfect example is antibiotics. So if you have antibiotics, what was shown before the antibiotics is going to be completely different after. And things like that, I think we have to get to a point where the data from the microbiome can become useful in a way that we can personalize medicine, especially for me, for GI medicine, to say, okay, your microbiome is like this, and if we manipulate it in a certain way to affect change, it's going to be like this, and these are the results you're going to get. I mean, that would be really cool for me, because then we're really moving away from pharmaceuticals and highly, highly personalized, in some circles call it precision medicine, but very individualized, personalized care based on basically just your bugs and the bugs that have been living with you.
Yeah. Do you know of any research that you're waiting to hear the results of that would shed light on some things you're interested in?
I really like the whole fecal transplant space, and there's a lot of clinical trials that are being done outside of C. difficile. So at this point, the only FDA approved indication for fecal transplant, that's literally just transferring poop from one person to another, is for C. difficile that hasn't really responded to any antibiotics. But of course, now that microbiome is all over the news, it's really linked to everything else too outside of the GI tract. I mean, it's been linked to mental illnesses, also cardiovascular disease, metabolic diseases, so much more beyond that you have to wonder, well, if the obvious question is, if you just transfer a healthy person's poop into someone who wants to change one of these things, well, what would happen over the long term? And even beyond that is, how do we affect people when they're first born? Because that's when we know that the microbiome is changing like heavily, and becomes more stable later on in life. So it's like twofold. Can we do something if someone is an adult and manipulate that? And is fecal transplant the way to go? And if so, then, we have to wait for the studies from the clinical trials to come out to say that, one, this does affect something and it's safe. I mean, those are the biggest things, that it's efficacious and it's safe. And then also, what population can this be applied to? That's really, it's really necessary to get that kind of data, is how many people, how many participants were in a study like that, and can this be applied to everyone, or is it supposed to be applied to just certain people? And it's so new in that sense, but that's something that I'm looking forward to see the clinical trials that are doing fecal transplants outside of that indication of C. difficile.
Yeah. No, that would be interesting. I mean, there's a lot to figure out.
Mm-hmm.
I've heard that it's not just the microbiome in our guts. I mean, there's a virome, there's parasites, there's fungi, there's yeast. I mean, there's so much in there.
Archaea. And I think it's a really beautiful story, I think, of the microbiome that we have. If you think about it, these bugs have been on this planet for way longer than human race entered sort of the existence of Earth, and how our species have evolved with these organisms that have been here before. They're way more adaptable than we are. They change, they cross, they share DNA with each other. It's quite incredible how crafty the microbes are. but that it's not just us, that we evolved with them. And there's sort of this entity that now has become into light of, oh wait, maybe we shouldn't just kill, like bugs are all evil and that all of them have to be eradicated, but that we have to foster these organisms that we're all host to in a good way, because one, it affects our health, and two, it affects even generations beyond that and everybody around us too, because I mean, we share bugs with each other, especially like you can imagine with spouses and partners. So it's this idea that we're not just a species that's a species alone, but we also have evolved with all of these other organisms in a very beautiful way in order to survive and mate. I mean, that's the goal of the microbes too, is survival and propagating the DNA into the next generation.
Very good. So what's the best way for people to, I guess if they're local to you, they can come see you, but how can they find out more if they have, a gastrointestinal problem, or if they want to learn more about, the microbiome or gut health? Any recommendations in general?
The American Gut Project is spearheaded by Rob Knight and some other great researchers like Jack Gilbert too. I even just started there. I became a citizen scientist. I submitted my poop that way and started learning. And I like that it's researcher-led and it's open source, and it's really kind of forwarding the science of microbiome. So that's kind of like one thing, is like as kind of a regular person, what can I do to forward this research? And then two, for me personally, I mean, I have a website. It's Dr. like Dr. Sam Nazareth, SAM Nazareth, like, NAZARETH.com. That's where you can find like information on some articles that I've written and contact for my practice. But just generally the microbiome space, there's so much out there, but even contributing to science by the data, because that's really what we need, is more data, and how that fits into the bigger scheme of things. It's really, really important.
Very good. Well, Sam, thanks for coming on the podcast. I appreciate it.
Thank you. Thank you for having me.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.